now that we're familiar with the idea of the dot product and two vectors being orthogonal, we can move towards the idea of the span of two vectors. That's what we're getting. Okay? And notice, perhaps the first thing you learned about when you learned about vectors is how to add two vectors. But we haven't yet talked about that. Okay? Because it hasn't been relevant yet. But the sum of two vectors is the element-wise sum of their components. Now, the issue is that when I defined the dot product, I said it was the sum of the element-wise products. And they both say element-wise in it. But the key to remember here is that the dot product results in a single number, but the sum results in a vector. Okay? And so I liken this problem to when in DSE 10 you were doing things like df.groupByX.sum.sortValues.index or something like that. Right? It's like the kind of thing where you'd write 7 pieces of baby pandas code in a row, and it's like hard to keep track of what meant what. Right? And what we encouraged you to do was say, okay, well, what does df.groupBy do? What does adding.sum do? What does adding.sortValues do? What does adding.index do? What does adding square bracket 0 do? You have to keep track of what every single object means. The same is true here. Shortly, we're going to get to these like linear algebraic expressions that involve dot products and sums and matrix vector multiplications and all this other stuff. And it's going to get confusing to know what you're even looking at. Like, are you looking at something that equals a single number or a vector or a matrix? And it's like important to keep in mind like what kinds of objects you're dealing with. Sound okay? All right. So, visually, when we add two vectors, what we typically do is we say, hey, well, I've thought of my vector as starting from 0, 0 and moving to this point, but vectors don't actually have a position, they just have a direction and magnitude. So, to add u and v here, what I can do is I can imagine u as just starting here and going there. And to add u and v, my setup, oops, good enough. Try one more time. I can connect u and v tip to tail and just go directly from the start of v to the end of u, like that. And the result is u plus v. I could have done it the other way by shifting v up here, and that would give me the same vector too. Do we agree? I could have gone this way, oops. Could have gone this way or this way. And you can see u and v kind of form this like parallelogram. And the diagonal of the parallelogram is the sum of u and v. Okay? Now that's adding two vectors, but we can also scale vectors by some constant. So for example, if I'm looking at 2u here, or sorry, I'm looking at u here, negative 2u might look something like this. It's twice as long as u and points in the opposite direction. That's how to interpret this graphically. The 2 means it's twice as long, and the negative means it's in the opposite direction. Okay? And so, if u is 2 and 4, a negative 2u might look something like negative 4, negative 8. Do we agree? Okay, so then I could say something like, hey, add negative 2u and v. And what's that going to look like? Well, you take v, you shift it down here, something like that. And so negative 2u plus v would bring us like this vector. Sound okay? So negative 2u plus v would bring us here. Questions with adding and scaling vectors?